Of an impeller of a centrifugal pump at inlet and outlet are 20 centimeters and 40 centimeters respectively. Determine the minimum speed for starting the pump if it works against a head of 25 meters. So here is given diameter of an impeller of a centrifugal pump at inlet and outlet. So we have to find minimum starting speed of the pump if it works against a head of 25 meters. So head against a pump works. Head against a pump works is known as manometric head. So here is given in this question given manometric head. Manometric head. So manometric head denoted by HM is equals to how much given? So in this question is given 25 meters. So diameter of impeller. Next given diameter of impeller. So diameter of impeller at inlet. So di is equals to d suffix I, diameter of impeller. Di is equals to diameter impeller at inlet. So at inlet how much? 20 centimeters. So diameter of impeller at outlet. At outlet. So d naught is equals to 40 centimeters. So diameter of inlet at diameter of impeller at inlet 20 centimeters. Diameter of impeller at outlet 40 centimeters. So here we need, at last we have to find minimum starting speed so nothing but n. Okay, na? So we have to find n, minimum starting speed required for the centrifugal pump. Okay, na? So we have to find n. So what is the formula? So we have a formula for manometric head. So for minimum starting speed, so what is the condition for manometric head? HM must be equal to, manometric head must be equal to U2 square by 2Z minus U1 square by 2Z. U2 square by 2Z minus U1 square by 2Z. Okay. So this is a formula for minimum starting speed. So we are going to use this formula. Okay. Now, so what is the common? Here we have common denominators. So HM is equals to, it can be written as U2 square minus U1 square whole divided by 2Z. Okay, na? Now let us transpose 2Z to left hand side. Division becomes multiplication. So 2G HM is equals to U2 square minus U1 square. Now, what is the value of G? G is acceleration due to gravity 9.81. HM 25 meters is equal to U2 square minus U1 square. So if you calculate this, you will get 490.5 is equals to U2 square minus U1 square. Okay. Now, here what is U1, what is U2? In this formula, what is U1, what is U2? So U1 means tangential velocity at inlet. So tangential velocity at inlet is given by pi di n by 60 meter per second. And what is U2? Tangential velocity at outlet. Okay, na? So tangential velocity of impeller at outlet. So pi d naught n by 60 meter per second. Okay. Now, so let us find ut square minus u1 square. Okay, first. So let it be equation number 1. So here we need ut square minus u1 square. Now, u2 square minus u1 square is equal to u2 square means pi d naught n by 60 whole square minus pi di n by 60 whole square. So we can write it as pi square by 60 square d naught square n square minus pi square by 60 square di square n square. Okay, now just distribute this power 2. Now what is the common thing here? Pi square by d naught square, and write remaining expressions d naught square n square minus di square n square. So we know that d naught square d naught is equal to 40 centimeters and di is equals to 20 centimeters. Before that, let us make some unit conversions here. See, 20 centimeter, we know that 1 centimeter is equals to 1 centimeter is equals to 10 to the power of minus 2 meters. Now 20 centimeters is equals to 20 into 10 to the power of minus 2 meters. If you calculate further, you will get 0.2 meters. So similarly, 40 centimeters is equals to 40 into 10 to the power of minus 2 meters. If you simplify further, you will get 0.4 meters. Okay, now we have diameter of impeller at inlet, diameter of impeller at outlet. Now substitute those values here. So pi square by 60 square, pi square by 60 square, d naught square. So d naught square value is, how much d naught square? 0.4 whole square n square minus di square. So di square value is 0.2 whole square into n square. Okay, now let us take out n square out of this expression. So n square common, take out n square. So pi square by 60 square into 0.4 whole square minus 0.2 whole square into n square. Now calculate value of this. So pi square by 60 square, 0.4 whole square minus 0.2 whole square. You will get this value around 0.000329 into n square. Therefore, u2 square minus u1 square is equals to 0.000329 n square. Okay. Now, from equation 1. So, what is equation 1? Here, equation 1 is 490.5 is equals to u2 square minus u1 square. So, now we have x value for u2 square minus u1 square. So, put its value in this equation. Put this value in this equation. So, I will get. So, u2 square minus u1 square is what? 490.5 is equal to 0.000329 n square. Okay. Now, n square is equals to 490.5. Transpose this value to left hand side. Multiplication becomes division. 0.000329. Now, n square is equals to, if you calculate this, you will get around 1,490,881.46. Now apply square root on both sides. Because we need value of n, minimum static speed, n is equal to root over 1,490,881.46. So square root of this value is 1. Square root of this value is 1,221.01 RPM. Okay, na? This is the minimum starting speed of the centrifugal pump. This is the final answer.